My name is Sahar, and I'm the CEO of Solaires, and it's a pleasure to be here. What we are doing at Solaires is a little bit different from the talks that has been discussed so far. We are focused on perovskite. We are not working with silicon. From the day one, we were focusing on single-layer perovskite. And the way that we started was to start by developing the material itself. So developing perovskite material has been one of our biggest focus, and then moving to the module fabrication. However, again, our module fabrication and the focus is also different from what we have heard so far. The initial focus that we have right now is to address the energy generation from indoor light. And then in the future, we will focus on the outdoor lights. So what I'm going to talk about is through basically how we moved from the initial steps that was developing material and developing our solar cells and solar modules inside our lab all the way to now what we're doing, which is the mass production of our PV module. Again, that's good that we have heard so many good talks, so it makes it easy for me because we already have heard these challenges from other presenters as well. So when we talk about material, the supply chain of the material is very important. The supply chain of silicon has been risky because of the geopolitical issue that we have. But the benefit that perovskite has is that we have seen that we can extract and purify perovskite material and precursors around the globe. So we're not necessarily limited to, let's say, Asia or like Southeast Asia for one specific type of material, which makes it less risky in terms of the mass production for us. One thing that we know is that silicon, with the manufacturing process that silicon has in terms of the purification, they generate a lot of GHG during the mass production, which with the thin film fabrication, including OPV and perovskite, we are promised to reduce that GHG emission by 75%, and we're going after that. The other thing is that with silicon, that we all basically owe the PV technology to silicon, but we have reached to the innovation cap. We reached to the point that the efficiency or the innovation in silicon by itself is not improving or is not moving as fast. So now we're focusing on basically other technologies. We're focusing on improvement and innovation in other technologies, including perovskite. And perovskite has a lot to basically grow, and there's a lot of innovative areas in perovskite that we have seen over the past 10 to 15 years. We're all familiar with these cell efficiency graph from NREL. There has been done a lot of great work from different partners, from different perovskite research institutions and also manufacturers. One thing that we have to notice here is that most of these results come from a non-production facility and non-production environment. So when we look at the efficiency, which is great, the efficiency has been increasing month after month, year after year. We have seen a lot of great results coming, new papers has been published, but really we know that in the mass production line, some of these processes are not even scalable. When we're talking about scalability, we always have to think about these processes, can I actually like make it in a large size? Can I also keep the can I also keep the price low? Because that's another important part, that we have been kind of like focused on efficiency, focused on later on stability, and somehow we also need to focus on how in mass scale reduce the CapEx operational costs and basically expenses that we have during the manufacturing. And some of the processes that we have seen and has been published and has been recorded and reported are not really in a way that we will be able to mass produce in a competitive price advantage. So of course, we are talking about the scalability. How can we make things scalable? How can we make perovskite PV module scalable and make it available to the market? That's another question. When are we going to make our perovskite module available? When are we able to basically install it and basically be able to generate energy from